I'm a civil engineering technologist from SAIT, Southern Alberta Institute of Tech, and I've worked in construction since I left high school, actually. So I started early and I've stuck with it. I really enjoy it. Primarily the last 15 years have been dedicated to larger building construction, and in the last 6 years I've gotten involved more and more in mass timber types of projects. So done small mass timber projects and done the project that everybody's familiar with, which is Brock Commons, and more recently working on other mid-rise mass timber projects. So that's kind of where we're at.
So we'll have a deep dive into Brock Commons today. I think the audience in Australia might be familiar with when you came down. I think it was in 2016. I was a student at the time, and there was a lot of things I think that pushed me towards, getting into timber and mass timber. But, that was one of the many type of presentations that kind of inspired me in that direction. So can you tell us a little bit about the project and why timber was chosen as the preferred material?
So it was a time when mass timber had been discussed as an option. I wasn't part of the committee that actually chose the mass timber. I'm certainly glad they did. The discussion had revolved around for years about why don't we build with it in a larger context. Then there was an actual committee put together that applied to the provincial government to get a building permit to do this. So it's a special permitting group. It doesn't fall under our national building permit because nobody had ever done it. It's like a one-up at that time. And so that was part of the direction. Was also providing funding from Forestry Innovations. There was definitely some funding and some additional help there to get that project out of the ground and moving forward to basically showcase we can do this. We can do mass timber buildings. And thankfully we did that because we learned a lot from that.
Yeah, absolutely. And you used the post and plate system at the time, and it's not really that common yet in Australia, and maybe it is in other parts around the world. So why was the post and plate system utilised for this project?
It was just so simple a system for us. We looked at a different number of things to do. And one of the things is that we wanted clear span inside of the building. And so the post plate works really well with that. It also, because CLT is a two-way spanning option, we weren't really regulated to having to have beams to manage that extra span. So that was part of the reason the engineering went in that direction. Fast and App definitely could speak more to that because they really got into that. They dug into the weeds and actually figured out how to do that two-way spanning with CLT. But thankfully, that's the direction they took. Then we just lightened up the idea of how we were going to do that plate detail during the course of the construction. So we did preliminary testing. We actually built a mock-up of a floor and figured out that installation and what we liked, what we didn't like, and then moved that forward again and went to actually build it with a really nice simplified system.
Can you talk a little bit more about the mock-up and what learnings did you get from the mock-up, and as a cost benefit kind of exercise, how did it all pan out?
Yeah, so mock-ups are expensive. There's no two ways around it. If you're going to do mock-ups, you're in it for the millions, and that's an unfortunate fact. But the benefit of them is outstanding. We were able to study and try different things, like the different connection details, the different steel connection details, what made more sense, what was going to be more easily acceptable to receive, and how we're going to receive the plates. And then the other part that we learned from our mock-ups, which was huge, was our envelope panel detail, which would allow us the speed to keep going with the mass timber, it's a kind of a critical path part for us. So we had 3 different panels on that building. We didn't use any of those panel options. The envelope panel we actually used was completely modified from the learning we had from that template. So we tried 3 different applications. All 3 were a struggle, and then we went and took it and realized a new way to do it and a much faster way. And interestingly enough, I currently work with that group on other projects, and they work with multiple multiple other companies now as a result of that project. And we've developed even further how to get a much more simplified detail since we've done that. We learned a lot, even just from building the Brock Commons. We felt we could do better, and since then we've actually smoothed that out again. And the same thing with the CLT and the post and beam. We've actually further developed that onto our future projects. We've sweetened that to a much more simplified, a much more elegant way of getting what the architect's looking for in the building, which is exciting. It's just going to showcase these buildings to be much better, and the technology is moving that much faster.
Absolutely. I know that one of the pieces of technology where you really pushed the limits was the virtual modeling. And
it's amazing.
Yeah, it really was. And even though it was still a couple of years ago now, I haven't seen anything quite like it. Can you tell us what kind of virtual modeling you did and the process and how it improved the productivity for the project?
It's a lesson learning thing. So we did the virtual model. So what we normally would do before we even started virtual modeling is we do a method statement. And the method statement is an identification by the trade of how they're going to actually produce the work that they're going to do. So they tell you, I'm going to pick up this panel, then I'm going to pick up this panel, then I'm going to do this, then I'm going to do this, and this is my sequence of events and how it's going to happen. These are the safety procedures and everything we're going to put into play. And ironically, on the Mass Timber project, the first virtual model we did was the concrete. It was the concrete 2 towers. And it was after reading the method statement that we realized there was going to be a major problem with it, and they couldn't understand it. They had developed the plan, and they just couldn't see what we could see in the plan as critically wrong. And then we actually did the plan in a virtual. We took all the pieces and we virtually modeled how that installation plan would go in on a time delivery on the virtual model, and they could see it immediately what we were talking about. There's a problem, you're going to trap people in this place, and that's going to be a big deal. And after that, then we started to smooth out this process, and then we started to realize, well, maybe we're going to have other problems. We're going to have openings that we need to create. We're going to need to have extra space for things like safety platforms, and if something goes wrong, how are we going to rescue somebody? So that actually evolved a whole different language of conversations that for the entire team and all of the trades of, well, this is how we're going to do it safely. These are the things I need to safely do my work. And now everybody could understand what we were doing, right down to the detail where they could look at the virtual model. We were really cool about it. We put the model right online and said, you know, we're not keeping this information for ourselves. We believe really strongly in sharing information out to everybody. When we learn something really impressive, we want to share as much as we can because we want to promote the industry, not just ourselves. And by sharing it on YouTube, it allowed the trades to actually, one, show off to their families about what they were up to, and two, it allowed them to actually understand their schedule right down to the labor detail, which I think is really fascinating because it's one of the lost communication skills. Usually your project managers, your superintendents, maybe your foremans all have really awesome schedules. The detail, 3,000, 4,000 line items, we know exactly where everything's going, but we don't translate that conversation down to the people that are actually doing all the work. And by doing a virtual model, we didn't have to have daily briefs to that level of detail. Now they could actually see the daily brief because it was day 1, 2, 3, 4 of that cycle. They could look at the day of the cycle and go, oh, well, at the beginning of the day, I'm doing this. The middle of the day, we're doing this. And at the end of the day, if this isn't done, we can't start the next day. So it really helped communicate that right down through everyone in the site, right down to the guys that were cleaning up the site at the end of the day. And it opened up a really interesting communication, and everybody really enjoyed being a part of it because now everyone feels like they're part of a team. Now it's not management at the top and people at the bottom. It's now we're an entire team and we're actually all communicating like a team.
That's awesome. Are you seeing much more innovation more recently when it comes to building information modeling with project teams? One of the things we're seeing in Australia is like some on the team would be modeling a certain way, and then it ends up people rebuilding different models, and the coordination isn't always
Yeah,
perfect on projects. What are you seeing in
it's a
terms of that?
learning curve too, right? And so what I found, I find that too. Even now, we're still finding that. So what we've discovered is everybody wants to work in the model that makes them the most comfortable. And the key is to actually have a modeling company take all the models and be able to integrate them together. And so for us, we used a company called CAD Makers, and they were able to then take everybody's models and make it into their model. So the other problems is the level of details in each of the models. Like the architect may be working to a lower level of resolution and detail than the mechanical company is using, and the mechanical contractor and the mechanical engineer are at a much higher resolution. So those two things now don't talk to each other. So you need that other group that actually can marry all the information up together. And then as a project manager and a management group, we make sure that the important things out of each of the models is getting translated so that we can create a language that we can communicate back to the trades on site. So we might not be taking down to the infinitesimal, I don't need to know the screw detail out of the mechanical, but I do need to know the unit size. And I need to know what unit it is, and that needs to go now into this modeling so that that communication can actually translate right down to the guy that's lifting the piece of equipment, that he can find that information. So it becomes this really amazing form of communication that it creates an inclusiveness to the entire team.
Absolutely. So it was a CLT plate and glue lam post system, but you also had concrete cores for this project.
Yeah.
How'd you go with designing or in the design process, also the construction with two different materials, and what are the things that you had to get right to make sure using both materials still worked well?
Yeah, so one of the lessons learned for us for Broad Commons is like when we get into these really tall buildings, we need to seismically, we need to have these concrete columns, these great big concrete cores that are for our elevator shafts, and that helps us with our seismic stability. So when we go to a mid-rise, which is what we're involved in now, primarily, we try to stay out of this concrete because it costs a lot of time. The concrete cores were about an extra 3 months, and we've now eliminated that completely by going to steel and CLT, so that eliminates that issue, and we can actually build much faster this way. So, and then so by doing that, now we've got a different trade on board. So on our projects now, we're seeing you have the CLT installation and your core installation. So your core goes in with your steel, immediately followed by your CLT, immediately followed by the next day, we're having an envelope panel put on, and then we're actually bringing in drywall in a lower level, and we're pouring concrete in the building. The concrete topping creates a really nice way of tanking so that we can protect it from water damage from like the elements like rain and snow or whatever other elements we're dealing with. That gives us a level of protection, and then we can actually start working below and start doing the installation of drywall, and then get us ready for starting finishes, like things like our rough-in mechanical and electrical, and then following through. Our cycle for rock, and actually most of our projects, is a 3-day cycle for our structure and envelope, which is intense. So it requires that level of detail, and that takes you back to that modeling and that being able to communicate throughout the entire trade group where you need to be, what the expectation is, and what the timing looks like.
That's absolutely unbelievable. A 3-day cycle. Is that
it's really hard to explain to somebody new. Like we're working with a new developer right now. They've seen the Brock, and they've seen other stuff that I've been involved in, and they're just like, we can see it, we just don't get it, but we believe. I'm like, well, it's a good thing because it's going to go fast, and then it's actually that education of learning how fast it goes so that you don't fall behind in the interior trades. That's a critical path that's often lost on these projects because it's a stumbling block of understanding. It goes so fast on the structure and envelope, and if you're not prepared for that, everything on the inside it struggles behind at a really slow pace. So we've taken that a CLT and the awesomeness of mass timber and its predictability and precision, and now we're actually prefabricating everything that we can prefabricate into the building and having it delivered, and it just installs. Like all your millwork, all your cabinetry, it installs within millimeters, which is remarkable and unheard of in a construction site.
Yeah, absolutely. Well, 3 days, and it's still pretty early days in terms of this type of construction. Do you think it can be pushed further to even become more productive? And what are those elements you might tweak? You mentioned going to a steel core as one thing. Is there anything else on site in terms of lifting or anything like that, or craneage or anything like that?
The craneage, I mean, I'd love to get to a site that I actually have enough room not to have a crane inside of a building. That would make my day every day of the week. But most of our sites, we actually really chase the sites for mass timber on extremely small sites. So we're looking at like places where you'd have basically a house dwelling, and we're now looking at putting a 5-story residential building there or an office building there. And the purpose behind that is to actually densify in locations like in downtown cores, which is great, but now we're still struggling. We have to deal with, well, where do you put the crane? And the crane still tends to want to land inside the building, which is a bit of a pain. It takes more time, and it's a little bit of a slower show. But at the other end of it, we finish up much quicker with mass timber, so it goes quick. And so that there's a balancing act that needs to be had there. Faster than 3 days, I mean, we probably could do this next one in less than that. But I think that 3 days is pretty aggressive, and it benefits the structural guys, but doesn't benefit the guys working on the inside of the building to go any faster. We need to give them time to actually install their product. And so we actually take a day off the schedule every 3 days and give that to them so that we don't lose sight of the whole product. It's really exciting to see the big flash of like one day you have no building, a month later you have a building and a roof, and it looks like, wow, are we moving in tomorrow? And the reality is, no, you're not. There's so much work to do on the inside. So learning to pre-manufacture as much as we can on the mechanical, the electrical, the millwork, and try to find slimmer and cheaper ways to deal with drywall. All those things, we're continually working on those, and that's still tending to evolve and be discovered. So it's exciting times though, because these are all new things. This is all new stuff for the majority of us who've been doing the same thing for years and years, and now we're playing with something that's it's like the brand new toy car. It's so much more fun.
Yeah, no, absolutely agree with that. As we approach towards the end now, if you were to see a new project manager moving into this space, if you had to tell them what's the 80-20 for project management in this, what is the 20% you need to focus on to get most of the projects right, what would you say to them?
The hard part will be your finishing. It's going to be really easy. You're going to have an amazing set of trades to put your shell and your CLT and all of this mass timber and all of the exciting stuff, which is generally the hardest part in a regular conventional construction. Is going to go really fast. It's actually going to go quite smoothly. Your biggest trick will be to manage the finishing on the inside. And so it's learning how to strategize that installation plan and make sure that you get that nice continuous flow and you don't get stops and starts, that you actually figure out how to get that movement through the building. That's a really tough part. There's still a ton of drywall in these buildings, and that trade just gets bogged down with the amount of work it's quite remarkable how much they have to do compared to everybody else in that building. And when we're looking for logistics project managers, we're looking for people that are fundamentally logistics planning, like people that get timing and deliverables so that they understand that they're always planning for the worst case event every day. We're not in for, there's no long game on this one. It's the short game. These are sprints. So those are the types of planners we're looking for when we're looking at new project managers that are moving into this. This is going to be really intense, and all your work is going to be way up front before we even put a shovel in the ground.
I saw last month, I think it was, that Canada had some code changes as well. What do you see? Can you tell us about the code changes that you saw? And and going forward, do you see a lot more exposed timber being the norm, or drywall construction and covering the timber is quite a bit.
Yeah, I think that the drywall is still a conversation we regularly have. It's still in our code that we have to do the drywall, but there is more testing happening every day to prove out that mass timber is not a high-risk product. So that's starting to change out. And we're starting to do more alternatives reports, so that gets us to that next level, right? Awesome part of this is our NBC, our National Building Code, has moved to a 12-story mass timber without special permits now. So this is a remarkable change. We've also had early adoptions from many of our cities that have their own building codes that have adopted it, and so therefore much easier to move forward and to get these projects on the go. We don't having to jump through so many hurdles like we used to. So those are all exciting things. Keeping in mind, like it took centuries for construction of concrete to get to where they are. And we remember the moments when they figured out to put rebar in concrete. I mean, we've got a long way to go with mass timber, and we're already evolving at a much faster rate. Mm-hmm. So there's exciting times for this product for many years to come. There's still lots of people that are very nervous of the product because they attribute it to a stick frame, which it's not. It doesn't behave like stick frame. But people, as they become more knowledgeable and it becomes mainstream conversation, there'll be less of that fear of a new product and more adaptation to it. The other really interesting things that we're learning about is our acoustics and how to manage our acoustics in the buildings better and better. And we're coming up with new tricks and tips and things that we can work with. So we have more tools in our toolbox on how to manage some of the things that have been long-term concerns. So lots of learning.
Absolutely. And what other projects have you got in the pipeline at the moment, Karla?
So currently we have 2 to go in the ground this year. They're going to go in the ground in September and then in December. And they're both residential projects, 100-unit residential projects. They're very different. They're both 100 units, and that's about where the similarity ends. One's a 4-story mass timber. It's a 6-story building, 4-story mass. And then the other one's 9 stories, and it's 6 stories of mass timber. And really exciting projects. They're on very difficult soil condition areas, and this just highlights how awesome mass timber is. The footing constraints just aren't there that we would have if we had a concrete building. So we're a much lighter building. It's much easier to build on these really difficult soil conditions, and it's really exciting days because we'll be starting at the same time a conventional concrete building starts beside us. And they're very similar in size and massing, and we'll get to see who finishes first.
We had in Australia, we had that same thing with Forte. Actually, it was going back to 2012, but it was the first serious mass timber building that went up, and there was just the images, and the concrete hardly got out of the ground, and the CLT, the 10-story CLT, was up in a very short period of time, relatively.
I can't. It's going to be rough for them. I feel for them because it'll be really tough to watch the other site, because our plan is to actually start our site a few weeks later than they do.
Love it.
So we know how this is going to work. So and it's pretty cool. I think the big lesson I've learned over the course of all of the mass timber stuff is for us as we're now a pre-construction management team. I work with a partner, and we get involved early with the companies that are getting interested in mass timber. Basically, if you have a sketch on a napkin, it's time to call me. And we started getting involved early about who do we pick for the right consultant teams. We're matching personalities, we're matching flexibility, and we're matching them to our developers so that we get a good conversation and we don't end up with something that doesn't look what the developer wants to have at the end. We're trying to make that actually happen for them. And then we match that into a really good trade team. We pick the trade teams to actually complement our consultant teams. Mm-hmm. And so the beauty in this is you end up with a really awesome team-oriented project, which is what everybody wants to hear. But the benefit is mass timber moves so fast, we can't have clashes of personalities. We actually need everybody to work really efficiently together and very quickly. They need to be very, very comfortable to pick up the phone and ask for help if they don't know what they're doing. instead of that fear factor of like, I'm going to teach you a lesson. That's not a part of this conversation. It's more of a, okay, how do we get it done quicker? Or how do I get this to move along faster? And it's a really interesting change and shift in the way things are looked at. And we also price early. So we start pricing early to keep control of the budget through the whole thing. So when we see things that are going sideways, instead of like getting married to something that doesn't work for the project, we actually start pulling it back and say things like, well, that steel is actually not working for the project. Maybe we should look at something else that would work better. And we don't get hung up on one or two things. We've designed all the work, we've done all the work, and we're stuck. No, we haven't got stuck. We're just like, oh, the pricing doesn't look good. Let's shift gears and find something that fits. We're finding that type of construction process is working much better for our groups, and it's much faster. And nobody's wasting time, so nobody's getting frustrated.
Yeah, I love it. It's a bit of a culture change that, putting your hand up when you don't know, because you're a paid consultant and you're paid on the job to know everything, but at the same time,
nobody knows everything.
That's right.
But you should know how to ask, and you should know how to reach out for help. That you should always know. But you can't know everything. I certainly don't know everything, but I do know people that know their stuff, and that I can rely on them to help, and vice versa. They also know how to reach out for help. It's just such an amazing shift, and it was something that we highlighted in Brock Commons, and we've really, really pushed for that shift in our culture and the people we're working with. And it's just amazing because the projects work so much better, and they're so much more efficient and faster because everybody's happier.
Yeah, 100%. If people want to find out more about you, Karla, where should they go?
We're Hive Projects now. Myself, I have a QS that I work with, and we literally focus entirely on mass timber and passive house. So it's info at hivecm.ca. That's our email address, and easy to find us there. And I'm easy too. It's Karla. It's Karla with a K at hivecm.ca. And definitely reach out. We have no problem answering questions and doing what we can. We want to see more and more people go this direction, because it's not just about building with CLT, it's about building smarter buildings. It's about building really great hybrid buildings that are really smart and efficient, and it showcases that humans are actually evolving and we're getting better at this stuff.